Good morning or afternoon. So we're looking at polynomials today, Tuesday, March 9th. So I have this note sheet for you. So if you don't have this yet, please make sure that you pause the video and get these passed out because you'll want this to go along with our notes today. But our main topic today is looking at end behavior of a polynomial function, of any polynomial function, and then going back over extrema and degrees and intercepts and all that good stuff. So to find end behavior, we are going to look at the graph on the left and the right to figure out what's happening on the top and on the bottom. So this is how I always write my end behavior. This is like the standard starting off, and it reads as x approaches positive infinity, f of x approaches, and I figure it out. And then as x approaches negative infinity, f of x approaches, and then I figure it out. So these little arrows, I read it as x is approaching negative infinity, and then here I read it as x is approaching positive infinity. So if you remember from yesterday, my domain of any polynomial function that we'll be dealing with, my domain will always be negative infinity to positive infinity. So I'm going to look at each sides of my domain. So negative infinity is always on the left side, and positive infinity is always on the right side. So the order of these can go in any order, but whenever I have the positive infinity, I'm going to look on the right-hand side. And then whenever I have the negative infinity, I'm going to look on the left-hand side. And for my polynomial functions, typically it's either going to point up or down. I could point out, like if I had an asymptote, but for our polynomial functions, one of these will be positive infinity, the other will be negative infinity, or they could both be positive or both be negative infinity. But I always look left and right. So I'm going to go through a few examples. These 4 examples are blank, so if you would just sketch the polynomial function along with me. So we're going to look at a fancy 5th degree polynomial here. It's degree 5 because I go down, up, down, up, down. So in 5 different directions. But my end behavior here, I'm going to try, I'm sorry. I'm going to fill this out. Okay. So as x approaches positive infinity, which is the right-hand side of my graph, and put a right, an R for the right-hand side of my graph. So on the right-hand side of my function, for my x approaches positive infinity, this is the right-hand side, my arrow is pointing down. So the lowest f of x, or y value function value that I can use, is negative infinity. And then as x approaches positive or negative infinity, this will be on the left. So here's the left side of my graph. On the left side of my graph, it's pointing up. So my y value is pointing up to positive infinity. Okay. Looking at an example for number 2, we'll make an M graph. So this has degree 4, up, down, up, down. And I'm going to look for my end behavior again. So as x approaches positive infinity, this will be on the right. This is the right side of my graph. I'm pointing down, so it's going to go to negative infinity. And then as x approaches negative infinity, which would be the left-hand side of my graph, here's the left-hand side of my graph, it is also pointing down to negative infinity. So we can have a positive and a negative infinity from my end behavior, or we could have something that's the same. It just depends on your graph. It just depends on your graph. So I'm going to look at the next 2 examples here. I'm going to make a W graph here. So for my end behavior, I'm going to look as x approaches positive infinity, which is the right. The right-hand side is going up. The highest y value I can use is positive infinity. And then as x approaches negative infinity, which will be on the left side of my graph is also pointing up. That value for y will be positive infinity. All right, and then one more. We'll make this degree 7. So 1, 2, 3, 4, 5, 6, 7. Looking at my degree, as x approaches positive infinity, which would be the right-hand side is going up, which will be positive infinity. And then if I look at the left-hand side of my graph, as x approaches negative infinity, is going down to negative infinity. So I have some rules, and we'll talk about some rules on Wednesday, but I want you to evaluate what is happening in the graph. Look as x approaches positive infinity on the right, x approaches negative infinity on the left, right and left, and then you'll have either positive or negative infinity in dealing with the y value. Okay. These 3 examples are functions where we have the equations. We're going to have the equation in here. So I want to make some generalizations about these 4 before I move on. So if I look at question number 1, this has degree 1, 2, 3, 4, 5. Looking at my directions, so it has degree 5. And I used a positive and a negative infinity for my end behavior. Number 4 has degree 1, 2, 3, 4, 5, 6, 7. And I'm using a positive and a negative infinity for my end behavior as well. Anytime you have an odd degree, the end behavior will use a positive infinity and a negative infinity. You just have to determine which one's which, but you will always use both of them. If I look at my examples for 2 and 3, number 2 has degree 4, 1, 2, 3, 4. And I'm only using negative infinities here. Number 3 also has degree 4. And I'm only using positive infinities. So if you have an even degree, you will use negative infinity or positive infinity, but not both. So you'll always look at the left and the right, so you always use a positive and negative infinity for the x's, but what I fill in for my blanks for my f of x will depend. So if I have an odd degree, the highest exponent is odd, you'll use a positive and a negative. If I have an even degree, I'll either use both of them being positive infinity or both of them being negative. Okay. What determines which one to put positive or negative, or when to put the positive and negative? It's all about that leading coefficient. So if the leading coefficient is positive, then the right side of the graph goes up. If my leading coefficient is negative, then the right-hand side goes down. So if the leading coefficient is negative, the right side of the graph goes down. So I like to draw a rough sketch, and it doesn't matter where it's touching the x-axis or the y-axis to look for my end behavior. So I'm going to give you a few examples here. Algebraically, we can always use our graphing calculator to help us out, but we're not there yet, to determine what my end behavior is. So for my first one, let me rewrite it again. So f of x is equal to negative 3x to the 4th plus 6x squared minus 8. That first term will determine my end behavior. So my degree is 4. I know my 4 is a little bit squishy in there. My degree is 4, which means I have an even degree. So I'm going to draw a sketch of this function, starting with the right-hand side. So my leading coefficient is negative, so the right-hand side has to go down. I'm going to draw in 4 different degrees. So I'm going to go up, down, up, down, up, down, up, down, up, down, from the right to the left, because the right side has to go down. So here's 1, 2, 3, 4. So here's a super rough sketch of what my graph could look like. It does have degree 4, 1, 2, 3, 4, and the right-hand side goes down because I have a negative leading coefficient. Well, my domain of negative infinity to positive infinity, so here's my right side. My right side is going down to negative infinity. My left side, negative infinity for the x's, is also going down. So I had an even degree, and I used both negative infinities. Right, my next example here, we'll do 7x to the 5th minus 3x squared plus 12. So it's all about that first term, the leading coefficient and its degree, to help me determine the end behavior. So since I have a positive leading coefficient, the right-hand side will go up. So I'm going to do my up, down, up, down, up, down, up, down, up, down, backwards until I have 5 different directions. So 1, 2, 3, 4, 5. So I'm not really concerned about x-intercepts, y-intercepts. I'm just looking at the arrows at the end. So the right-hand side of my graph is going up to positive infinity. Left-hand side of my graph is going down to negative infinity. So I have an odd degree. So I have the positive and the negative infinities. I like to say if you have an odd degree that the ends are at odds with each other. They'll be in different directions. And if I have an even degree, then they can even out or match up, either going to positive or negative at the end. All right, so one more example like this. F of x is equal to 5x squared plus 6x plus 1. So that first term with its leading coefficient and highest exponent will help me out. So positive leading coefficient, so the right-hand side will go up. Have degree 2, so I need to go in 2 different directions, so I'm going to go down, up. Right? So when you're finding the end behavior for these, you're going to graph them backwards, like reading it backwards. As x approaches positive infinity, which is the right-hand side, my graph is pointing up to positive infinity. As x approaches negative infinity on the left-hand side, my graph is still pointing up to positive infinity. I did have a even exponent, so these should match. Okay. All right. So, quick review of stuff on the back. All right. So, extrema. Extrema are the max and the mins in the graph. I also like to call them the peaks and the valleys. They can be the absolute highest or relative highest. They can be the absolute minimist or the lowest minimum. The absolute. I think I said it backwards. All right, so if you are given a graph, you're going to take the terms and subtract 1 to get the least possible degree of the polynomial. So we did this yesterday, that we talked about the degree, but here I have the number of terms. So I'm turning here, here, and here. There are 3 terms. There are 3 extrema. I said the wrong thing. We're not subtracting, my bad. That's for this one here. So sorry. So I'm going to take the number of terms and I'm going to add 1 to get the degree. So my 3 terms are 3 extrema. I'm going to add 1 to it. So my least possible degree is 4. So if I look at my direction, down, up, I'm going in 4 directions. So my degree needs to be 4. Now my degree could be higher than 4 because I could have some multiplicity that I don't see in my graph. So don't do any extra. All right, so if you're given the function, you're going to take the degree, and now we're going to subtract 1 to get the number of extrema. So this graph, or this function, has degree 3. I could think in positive leading coefficient, so right-hand side goes up, 1, 2, 3. So the number of extrema that I have is always 1 less than the degree, because it's the number of terms. So the degree is the number of directions, So you always have one less term you're going to start off. So there is a, for this graph, there are 2 extrema. We're not finding them, we're just saying how many. All right, so got a few examples here. For numbers 8 and 9, we're going to look at the least possible degree. So here in this graph, I have 2 extrema. So if I add one to it, the least possible degree for this is 3. And I can also think up, down, up for my directions. This one here, I have 3 extrema. If I add one to it, it will give me a least possible degree of 4. And I can see up, down, up, down. So it's going in 4 different directions. Sorry, my pens are not very smooth. All right. So looking at my next 3 examples, y'all need to write in equations for numbers 11 and 12. We're going to state the number of extrema. So number 10, it has degree 4. So I have 1 less extrema. So there are 3 extrema for this graph. I wanted to graph it. It's going to go up on the right. 1, 2, 3, 4. And I can see there are 3 extrema. For number 11, we'll look at the function negative x to the 5th plus 3x to the 4th minus x. It's all about that degree. So I have degree 5. So there will be 4 extrema on this graph. All right, and then looking at number 12, if I have 2x to the 7th minus 3x to the 5th plus 5, my degree is 7. So I'll have 1 less. I will have 6 extrema. So to kind of summarize, come over here. So the degree plus 1 equals the number of extrema. And then the number of extrema, oh my goodness, I'm so sorry. My degree minus 1 is equal to the number of extrema. I apologize. The degree minus 1 number of extrema. So my extrema plus 1 is equal to the degree of the polynomial. So they're always 1 off. You can always sketch a quick graph. So like for number 12, I have a positive leading coefficient, so the right-hand side is going to go up. I'm going to go in 7 degrees. So 1, 2, 3, 4, 5, 6, 7, and then I can count how many extrema I have. All right, and then my last 2 examples down here, we're going to fill out these polynomial pieces of information, and we're going to draw a rough sketch. A rough sketch. So there are things that I'm picky about with my sketch. They include the zeros, the y-intercept, and the end behavior. Everything else is not important at this time. So I have 2 zeros. One is at negative 10, one is at positive 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then at 2. All right, my y-intercept is at negative 20. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 20. All right, so there's negative 20. All right, so I need to touch at negative 10, at negative 20, and at 2. My leading coefficient is positive. With a positive leading coefficient, 1x squared, the right-hand side is going to go up. I'm going in 2 different directions. So 1, hit that point, bring it back up, 2. All right, not the best parabola I've ever drawn in my life, but it works. So there are 2 zeros. They told me that they were. The y-intercept is a point 0, negative 20. I found that from my constant number. As x approaches positive infinity, which is the right, I'm going up. So that's to positive infinity. As x approaches negative infinity, that's on the left. I'm also going up, that's to positive infinity. And I can see there is one extrema. Degree 2, one less for the extrema. All right, and then looking at number 14. This one should be a nicer graph to graph. All right, so I'm given the zeros, which are at -2, -1, and 1. And then my y-intercept I can get from my equation here is at -2. So those points are important. My leading coefficient is a +1, so the right-hand side is going to go up. So I'm going to go 1, 2, 3, making sure I hit those points in my turning process. So I have 3 zeros. I had degree 3. They tell me where to touch the x-axis at 3 separate times. My y-intercept is at 0, -2. For my end behavior, as x approaches positive infinity to the right, it's going up, so that will be positive infinity. And then as x approaches negative infinity, that will be on the left. I go down to negative infinity, and I can see where my extrema are. There are 2, one less than the degree. So I have some homework for you to work on today in dealing with these concepts, so please work on that for the remainder of the class period. I will be collecting some homework on Wednesday, and we will also have a quiz after we do some review. See you guys tomorrow.